for the sir.
I think we have got our message that the class will start soon and sir will be here soon.
No, sir is there. Wait.
Okay. Prakash sir is joined, but he is on mute.
Yeah, good evening. So in the last video, we are trying to calculate, okay, we are trying to calculate, sir, space complexities already we have seen. So time complexities also, sir, we have seen for some algorithms. How we can able to calculate a time complexity from the basic algorithm to, sir, advanced level, we have seen very clearly. Okay, sir, next and after that, we will do today also, sir, some of the algorithms calculation, because some people may have a doubt. That's why we will take today also some algorithms and we will try to calculate time complexities for those algorithms. Okay, we will calculate for maybe 2 or 3 programs we will discuss, and then we are going to enter into some measurements, how you can able to measure these time complexities, right? Now, sir, coming to the next algorithm, what algorithms we covered? Sir, sum of n natural numbers. How you can able to calculate time complexity for this we have seen. Sir, now my next algorithm is nothing but I want to find out. Okay, I want to find out. Find sir, max element present in an array. This is nothing but my requirement. Okay, sir, I want to find out maximum element present in the array. Okay, so maybe you people don't know about this algorithm, but some people may already. So just I am going to write the algorithm, sir, max element. Okay, max element. So we have to take array, and then size is also important. Then, sir, after this, what is the first step? We have to calculate, we are going to assume a of 0 is nothing but my maximum element. That means what? Sir, the first element itself is the maximum element. Like that, I am going to fill. Next term, sir, for I is equal to 0, I will take 0 as a index. So I less than n, I plus plus. So then what we have to do? Sir, we need to compare this with the remaining elements. How you can compare? If whatever maximum value you have, if it is less when compared with a of I, so whatever maximum value you have in your hand, if it is less than a of I, then boss, your maximum is not a maximum. A of I will become your maximum. Sir, this is nothing but what we have. Then we need to close this if condition. Okay, sorry, we need to close this if condition. Sir, after this, what we have to do? After this, what we have to do? We need to close this for loop. And after this, what we have to do? Sir, we have to return that maximum value, whatever we have, and we have to end the algorithm. This is nothing but what is the algorithm. Sir, first I will explain the execution flow. Later, we will calculate the time complexity for this. Sir, let me take one simple example. Sir, I have array is equal to, sir, something like consider I have 1, okay, and then -3, okay, so and then 2, okay, so and then 4, and then 3, like this we have. Sir, what is the n value here? How many elements are there? 5 elements. Initially, this instruction will execute. Sir, my max is equal to a of 0. That means what? It is 0th location, first location, second location, third location, and fourth location. So max is equal to a of 0. A of 0 means what? 1. Sir, then I think here you can reduce the number of instructions by taking I plus 1, because first element already you have selected. Now you need to compare this with remaining all the elements, right? So self comparison is not required. Even if you do, nothing will happen, but unnecessary time waste you are going to get. So I will modify this I is equal to 0 to I plus 1 once if I finish this drawing. Then, sir, I is equal. I value will start from I plus 1. No, directly we can start from 1. Sir, from first location. What is the first location? The first location value is nothing but -3, which is less than maximum. What is the maximum? 1. Is the condition is true? No, condition is false. That means this statement executes. Then, so I will become 2. Sir, maximum is 1. Is it less than? Sir, 2. Condition is 2. Then your maximum will become, that's what you are doing here. Then when I is equal to 3, what will happen? Sir, now maximum value is 2, not 1. Sir, 2 is less than 4. Condition. Then your maximum value will become 4. Next, when I is equal to 4, what happens? Sir, 4 is less than 3. Condition is false. So when I is equal to 5, this is what last week so many people confused. This is called as n plus 1 iteration. Okay. Sir, when I is equal to 4, what will happen? Sir, condition is going to be failed, right? Because we are checking this condition. I is less than n. So 5 is less than 5. Condition is false. So the loop is going to be stopped. So finally, it will return max. What is the value of max, sir? Is it 4 or not? Right. This is the way how we can able to find out. Okay, how you can able to find out max element present in an array. So if this algorithm is clear for you people, then we are ready to find time complexity for this. Okay. So hope everyone got very clear clarity about this algorithm, sir. Okay. Sir, please confirm, friends. Do you have any doubts up to this? Everyone, please respond. Do you have any doubts up to this?
Sir, this I will be start from 1, right? And it goes up
Yes, sir.
to
Yes,
I
yes, yes.
less than equal to n.
No, not less than or equal to. Less than only.
Okay.
I told, right? I think you have understood. Right. Sir, shall we go for calculation of time complexity for this? Please confirm.
Yes.
Very good. Now, sir, you have to calculate the time complexity because already we have analyzed, right, how it is going to work. So it's time for you to cross check your answers. Okay. Right. Sir, we know first line it is going to take 0. So second line it is going to take 0. Sir, third line, can you please confirm? Yes. Third line. Yes. You can negligible or you can take 0. Sorry, you can take 1, not n minus 1. You can neglect or you can take 1. Sir, in previous algorithm, so I think we have not taken for initialization. So don't get confused. Let us take it as 0. Okay, let us take it as 0. But space will be there for that. Next, sir, fourth line. This is very, very important. Sir, can you please confirm how many times the loop is going to execute? Sir, everyone have to give clear clarity.
N minus 1.
I will give final result. N minus
1.
1. No, I think so. Not n minus 1. N times.
N times, yeah.
So because in previous example we have seen when it is taking I2, I mean 1 to less than or equal to n, then it is taking n plus 1. It is also n plus 1 only. But sir, in the diagram, wait, I will show that
It
diagram.
starts from 1, sir.
Yeah, good, correct. 1 minute, I will open that screenshot. Yeah, sir, you can able to see here. I told, right, we should not start from 0. We have to start from 1. The reason is first element already you have taken. Then what is the need? So simply you can compare in this area alone. No need to consider this first element. So we can reduce one comparison, right? So that one comparison I am minusing here. N minus 1 plus n plus 1 minus 1. Generally n minus 1 only. Every for loop will take n plus 1. Remember this. But if you are not comparing the first element, then n plus 1 minus 1. One comparison you are going to reduce. Okay, so like this n minus 1 plus 1 will become n. So just for your understanding, I am taking like this. So that one comparison, we are not considering first element. This is the reason what we have. Then, sir, as usual, fifth line, since it is a brackets, it will take a 0. Sir, sixth line, can you please confirm? Sixth line, can you please confirm how much time it is going to take? Sir, in the previous example also, if condition, how much instruction we have taken? N times it is going to check. But here, is it going to check n times or n minus 1 time? I have a doubt.
N minus 1, sir.
Yes, n minus 1. That is very, very important. Sir, I think some people are getting idea how this calculation is going to be done. Suppose if you people are confusing, sir, how it is n minus 1, no problem at all. Take it as n only. No issues at all. The people who are understanding, no issues. You can keep it as n minus 1. So the people who are getting confusion, leave it. Because when this loop is executing n plus 1 times, internal statements are going to execute n times. Because when the loop is going to enter, if the condition is n times condition will be true, one time condition is false. So that one time is not going to execute. Suppose if this loop itself is executing n times means, so one time false, n minus 1 times these are going to execute. Okay, right. Sir, what about seventh line? Because seventh line is the brackets, we can ignore. What about eighth line? Yeah, can you please confirm? What about eighth line? Okay, sir, here you have checked every element. So that's why almost half of the elements, because if it is array, again different approach. But here it is not an array. That's why we have taken half of the elements, because we know if you take 10 natural numbers, in that 50% even will be there, 50% odd will be there. But here that is not the situation. You can't give guarantee that maximum element is that element or next element. We can't give guarantee. That's why, yes, correct. It is also going to execute how many times? N minus 1. Ninth line, as we know, it is a 0. Sir, 10th line, as we know, it is a 0. 11th line, as we know, it is a 0. Sir, 12th line, as we know, it is a 0. Sir, what is the time complexity of this particular algorithm, like maximum element? So, what is the time complexity? Sir, n plus n minus 1 plus n minus 1. Okay, sir, total will become, so 3n minus 2. Okay, 3n minus 2. Yes, some people are feeling, yes, big O of n. Big O of n, correct. So that's why I told some people can ignore these values, no problem at all. You can ignore this value, no problem at all. If you want a correct value, this is the possibility. Depending on a n only, we are going to get the time complexity. Okay, sir, hope it is very clear for you people. So do you have any doubt up to this? Please confirm.
Hello, sir.
Hmm.
Hello.
Sir.
Sir, what happen if for loop start with 2, then it will be minus 2.
Yes, n minus 1. If for loop is going to start from 2, see here. So if for loop is going to take n, for loop is going to execute n plus 1, right?
Yes. Yes.
You are taking only n minus 1 comparisons. That means one comparison you are ignoring. Then
Yes.
n minus 1 plus 1 according to the formula. So you
Yes.
will get n, right? If you are ignoring two comparisons, what will happen? N minus 2 plus 1. That means what? N minus 1. Clear?
Yes, sir. Clear.
In some, you have taken only n minus 1. Where? In previous example, not n minus 1. We have taken n by 2 because it is sum of n even numbers. Continuation, not array. If it is array, we can't give guarantee that that element is even or odd. But if it is natural numbers, we can give guarantee. If you take 50 elements, 25 elements will be even. 25 elements will be odd. That's why we have taken n by 2. Clear? Kiran Kumar, not Kiran. Abhay Kumar. Kiran, I have not covered notations till now. Okay, tomorrow we are going to start notations. Clear up to this? Sir, requesting everyone to please respond. The time complexity of this algorithm, is it clear?
Yes, sir.
Yes, sir.
Right, friends. So now, sir, listen carefully. Now, just I'm going a bit advanced, sir. So I have some algorithms are there. Okay. I need to check how it is going to work, how much time complexity it is going to take. Just please try to understand these three algorithms I'm going to explain. So example number one, separate category. Okay. Sir, I want to perform sorting. Okay, sorting of an array. Sorting of an array. Okay. So first I will write algorithm. Sir, algorithm sorting. Okay. So I'm taking a array and n elements are there. I'm not writing any numbers, all these things directly I will take. Okay. Sir, in this, how you can able to sort direct code I'm going to take. So how I'm going to take, sir, for I is equal to 0, I less than n, I plus plus. Okay. So for j is equal to I plus 1, j less than n, j plus plus. Okay. So here, if your a of I is greater than a of j, if your a of I is greater than a of j, some swapping we are doing. T is equal to a of I, a of I is equal to a of j, a of j is equal to t. This logic is called as a swapping, sir. Sorting. First, I will explain this logic, how it is going to work. Have a look once. Sir, I have an array is there. Okay. Yeah, sir, please don't post anything on the chat window while I am drawing because it will be skipped. Okay. Sir, I am taking A is equal to, sir, something like I am going to take, so 2. Okay. Sir, then 4. Okay. Sir, next and after that 1 and then 3. Like this I have. So 0th location, first location, second location, third location. Now, sir, I is equal to 0, I less than n, I plus plus. So I is equal to 0. Okay. So I is equal to 1, I is equal to 2. Okay. I is equal to 3. Right. When I is equal to 4, the loop is going to fail. Next, j is equal to, when I is equal to 0, this loop is going to execute how many times? N times. When I is equal to 0, it is going to take j values as a 0 plus 1. That means 1. Okay. Then 1 plus 1, 2. 2 plus 1, 3. When I is equal to 1, sir, j values will become 1 plus 1, 2, 2 plus 1, 3. When I is equal to 2, your j values will become 2 plus 1, 3. Okay. That's all. When I is equal to 3, there won't be any j values. Like this, the iterations are going to be compared. Now, sir, we are comparing a of I, a of j. A of 0, A of 1. Sir, A of 0 is 2. A of 1 is nothing but 1. Sir, is 2 is greater than 1? Yes, I think here we can replace less than so that we will get a descending order. If you take greater than, we will get ascending order. If 2 is less than 1, is the condition is true or false? So the condition is nothing but a false. It won't perform. No, correct. Greater than only, right? Yes, greater than only. Sorry, sir. So now 2 is greater than. Condition is true. Then we are doing swapping. Sir, which is swapping? So 2 and then, oh, I'm getting confusion here. Let us rewrite. Sir, 2 is the 0th location, is greater than, condition is false, right? So this loop won't execute. Okay, this loop won't execute. This loop won't execute. Next, we are comparing 0th element with the second element. So 0th element is 2, greater than second location value is 1. Sir, condition true or false? So condition is true. Condition is true. Then swapping will be happen. Swapping means what? Here you will get a 2. So here you are going to get 1. Then, sir, I is equal to 0 and then 3. 0 means now latest element. 1 is greater than 3. So condition is false. It won't execute. So with this first element got sorted. That's all. So when I is equal to 1, Sir, what will happen? We are comparing first element to second element. First element is 4, second element is condition true, right? So swapping will happen. Here you are going to get 2, here you will get 4. Sir, next I is equal to 1, 3. Sir, 1 means we are going to get 2. Sir, 3 means we have already 3. Condition is false. So nothing will be happen. So next I is equal to, this element is also get sorted. So I is equal to 2 and then 3. Sir, what is the 2 value? So 3. Sir, condition is true or false? So swapping will happen. Here you will get 3, here you are going to get 4. Now this one is not going to execute. So you can able to see the updated array will become, sir, 1, 2, 3, 4. Like this we got. So it is a sorting. Sir, I will calculate time complexity for this. Just roughly I am calculating. For this line, how many times it is going to execute? We know it will execute n plus 1 times. Right? N times 2, 1 times to false. Sir, what about this one? What about this one? For generally, sir, it is a for loop, right? Definitely, yeah, we will calculate that later because majority of the students are posting. So I will take the screenshot first. Yes. Sir, now tell me, so this line, how much time it is going to require? Everyone, please respond. How much time it is going to take? Please respond, everyone. Just now I have given clarity for this. Yes, very good. So generally we calculated it is going to take how much time? N plus 1 time it is going to take. N plus 1 times it is going to take. Sir, now, just a minute. Yes. Sir, N plus 1 times it is going to take. Sir, what about this line? Can anyone guess how many times it is going to run? Yes, everyone.
N times.
N times?
Yes, sir.
Very good. Sir, normal for loop will execute N plus 1 times. Will you agree or not? Normal for loop will execute n plus 1 times, right?
Yes, sir.
Yes. But this for loop is depending on this for loop or not, right? That means if I is equal to 1, this will execute n plus 1 times. If I is equal to 1, 2, it will execute n plus 1 times. If I is equal to 5, it will execute n plus 1 times. If I is equal to 6, it will execute 6 plus 1 times. That means what? If I is equal to n, it will execute n into n plus 1 times. N into n plus 1 times. Yes, we can write like that. No problem here. What is the problem here? No problem. It will work. But sir, there is a slight change here. That part we will discuss later because we are starting from I plus 1. If we are starting from I plus 1, that means one value we are neglecting. In the previous example, we have seen how many times it is going to execute? N times. So here it is not n plus 1. It is only n. Will you accept this? Please confirm, everyone.
Pardon, sir.
Right. So it will become n square, right? N square. Just for our understanding, I am taking, sir. Consider this one as a square. Now, sir, now it is your turn. Please tell me how many times it is going to execute. You have to tell the correct answer for this.
Less than n times.
How many times it is going to compare? N square?
-1.
N square
N
minus
square
1
plus
or
1.
n square? Sir, plus 1 won't be there. Remember, when you are coming from top to bottom, it won't increase, it will decrease because this loop is executing 9 times means 8 times only true, 1 time false. So this will execute 8 times means, so in that 7 times true, 1 time false. When it comes to here, so it will reduce one value, right? So I can say n square minus, can I take like this? Can I take like this?
Hello, sir.
Ah.
Yeah, sir, you are saying that n square, right? Means -1. So in for loop also we are checking one time condition. So there we are taking n plus 1. So why we are considering not in this n square plus 1.
No,
Because-
sir. Here, see, this loop, consider this loop is going to execute. In previous example, we have taken n is equal to 4 elements, right? So 4 times true, 1 time false. Correct, right?
Correct.
So this loop, how it is going to execute? For first element, it will take remaining 3 elements comparison, right?
Correct.
For second element, remaining 2 element comparison. That means we are starting from by ignoring 1 or 2 values. Okay. So that's why, so n plus 1 minus 1, so that it will become n. How many times it is going to execute? Not exactly n. It depends on this loop. So that's why n square we have taken. Clear up to this?
Yes, sir.
So in this n square, false is also there or not?
Correct.
Are you getting my point?
Yes, yes.
So that false case we have to remove here, because so n square times this loop for loop is executing means n square minus 1 times 1 time false. So this will execute how many times? N square minus 1. That's what I am telling. If anyone is confusing, just ignore this. So now the time complexity of this sorting technique, what we have learned till now, is nothing but, sir, n plus 1 plus n square, okay, plus n square plus n square minus. Sir, what will be the total time complexity? I think, sir, 2n square, 2n square plus n, right? This is nothing but what we have. Big O notations, that part we will discuss later. Sir, clear up to this, everyone? No, this is theoretical validations. Who is that? Someone is asking, sir, is it validation for real-time complexity? No, it is theoretical computation. Time and space complexities we will calculate prior to the analysis. Before execution of the program, we will prepare. After executing the program, we can't give guarantee because it will be executed on processor. You can't give guarantee. Someone is asking, sir, please explain n minus 1. Please explain n minus 1. Okay. Yes, for swapping also it will take, just I'm concentrating. That's why especially I'm taking these examples. So I'm ignoring slowly these numbers and all these things. Okay. Just I'm concentrating how these loops are working. Clear, Vishal?
Sir,
Sure, sir. But on the 3 lines of swapping, like we've said, it's 2n square plus n.
Maybe
Could we not-
here one more n square, one more n square, one more n
Yeah,
square
yeah,
will
so
come.
it could be like 5n
So it
square.
5n square. But
Okay.
finally I'm telling, so it will comes under like something like big O of
Order
n
of
square.
n square
That's all.
only, because
So
that's the
that's why
highest
just, yeah.
polynomial. Okay,
So because some people are going to get confused, sir. That's why just I'm keeping something.
understood.
Please, yeah.
hello, sir.
Who is?
Sir, can you hear me, sir?
Yeah, yeah. I'm.
Sir, for the second loop,
Hmm.
sir, as the value of I increases,
Hmm.
so the value of n will decrease, right?
Yes, yes.
So it should be n cross n minus I every time.
Yes, yes, correct. But how much size is there? All these things also will be very, very important. But I'm skipping all those things. I'm not going in detail. But whatever you are saying is correct, because when I is equal to 0, we are comparing completely. Just a minute. I will show that diagram. 1 minute. So what he is asking a good question. Have a look once. This is also considerable, but just for because of confusion, I'm skipping that. Yeah, you can able to see here what he is telling. Sir, when I is equal to 0, you are taking 3 comparisons, no problem. When I is equal to 1, 2 comparisons. When I is equal to 2, only 1 comparison. When I is equal to 3, no comparison. That means when I value is increasing, sir, j values are decreasing. Then how you can take n square? It is wrong. Of course, no problem. But just I am considering for example sake, Slowly these things we are going to cover in our upcoming classes if possible. Okay.
Okay, sir.
Right. If someone is asking for time complexity in algorithms, I mean in interviews, how we validate our answer is correct or not. For time complexity measurements, so how many constants are there, how many coefficients are there, no one is going to check. So time complexity for this is nothing but a big O of n square. That's all. This is the answer. Even you can verify in the net. So if you ask for time complexity for sorting algorithm, it will be big O of n square or n log n, okay, or n by 2. Like this, it will be there. This is the final answer. If you calculate also, you will get the same thing. By ignoring this or by adding some extra comments also, if you take, you will get this only. That how you can calculate, we will see. So, but just for your understanding purpose, slowly I am bringing, sir. Okay. And
Sir,
someone, yes.
sir, I think what you're trying to say is like we can, I mean, we can ignore the fixed number like 1 and 2, and we always can focus on n. I mean, whether it is n square or 2n or something like that.
Yes, yes.
Okay, okay, got it.
Right. And someone is asking, sir, please explain again that n square, how it is going to come. Sir, very simple. Listen carefully. This loop is going to execute n plus 1 times because it is a for loop. We have taken one more for loop here. I can say this is nothing but inner for loop. Inner for loop means it is also execute n plus 1 times. But this loop is under the control of another loop. That means how many times this loop is executing, those many times this loop will execute. Because we have seen already inside the loop, if you are taking any statement, how many times this statement will execute means how you are saying, how many times this loop is running, those many times this statement will execute. Same thing, how many times outer for loop is executing, those many times inner for loop will execute. That's why, sir, n into n plus 1 is the answer. But sir, why you are not taking n minus n plus 1? Because, so here, when I is equal to 0, we are starting from 0 plus 1. When I is equal to 1, we are starting from 1 plus 1. That means we are trying to ignore some values. So for that, I am taking n into n plus 1, we will ignore one value. So that it will become n square. Clear? The person who asked this doubt. Clear? Pradeep, I think, yeah. Sir, example 2, sir.
Yes,
Listen.
sir. I have one question like for n square, 2n square minus 1, how minus 1 for line number, um, yeah,
This one,
that,
this one, this one.
yes, this one, sir. Yes,
See,
sir.
sir, majority of people are asking the same thing. Don't get confused, sir. So this one is going to work for n plus 1 times, right?
Yes.
That means n times true, 1 time false, right?
Yes, sir.
So this loop is going to execute how many times? N square times. That means n square minus 1 times true, 1 time false, correct?
N square time true minus 1
n
time
square,
false.
no, n square minus 1 times true, 1 time false. Maybe you are getting confusion. Now, Vinith, please answer this question.
Yeah.
This loop is executing 5 times.
Hmm.
That means 4 times true, 1 time false, right?
Correct.
So this loop is executing 7 times. Means what? 6 times true, 1 time false, right? So 7 place I am taking n square. 6th place, we can't take n square, right? N square, we are subtracting one value from this, right? Minus
Correct,
1 plus 1. 1 time false, n square minus 1 time true, right? So true times only this statement will execute, right? Because it is inside the for loop. So for loop is executing. So this times true, this times false means when it is true, then only it will enter.
Correct, sir.
So n minus n square minus 1 minus 1. Clear? I think you got answer.
Sir, I have one quick question. We
Hmm.
have two for loops here, right? Let's say if we add another for loop.
Yeah, I will explain, sir. We have an example for that. Don't worry.
Okay, sir.
Sir, simple answer, sir. It will become n cube. Okay. Right? One order is going to increase. N for one loop, n into n for next loop. If you have another loop, n into n for another loop, like that.
Okay, sir.
Yeah, we will see that we have one program. Matrix multiplication is there. That I will explain. Clear up to this, everyone? Siri Chandana, sorry, for every time we need to ignore false case and calculate. Yes, when you are executing for loop, you have to include false case. Once if you enter into that for loop, you have to ignore that false case. Something like a gun shoot, sir. When you are shooting the gun, that case will drop down there itself. Only bullet will move. In the same way, when you are entering into the for loop, false conditions will be ignored. True conditions will move, right? Chandana, correct? Sir, how with the code in debug mode will taking small value of n? No. You can refer that. I think I explained this algorithm. Please cross check Vasant one more time this video. Okay. I have explained with the help of example. Okay. Right, sir. Sir, now second example. What is the second example here is, sir, I want to calculate sum of two matrices. Sum of two matrices. For
Sir,
this,
that sorting array contains duplicates. What do we do, sir?
sir, even though if you have duplicates, compulsory the code is going to verify, right? Comparison has to be happen. If you take all the elements in ascending order also, definitely comparisons will be there. Because you are not seeing physically what elements are there. We are writing the algorithm. That algorithm don't know whether the data is in sorting order or not until it is entering into the live. Clear?
Yes,
Right. That's why a good question actually, but innocent question. Sir, have you observed if data is already in sorting? If the data is already in sorting, okay, then if the data is not in sorting, okay, so the data in sorting in ascending order, the data is in sorting, sir, in descending order. So if data is already in sorting descending order, sir, now I want to apply algorithm for this sorting algorithm. So assume I want to perform what you can say ascending order. If the data is already in sorting order, one performance you will get. If the data is in descending order, we have to do so much of homework. If the data is in shuffle order, we have to do at least some average. Sir, are you seeing in all these cases, the task is going to be performed. Even though the data is in ascending order, if you submit the data, task has to be completed. So comparisons, it will take care. But every time false case will happen. Okay. So that part also, we have one small note is there. Maybe in future, I will cover that when I'm dealing with the sortings. Okay. So which sorting is best? Sir, if the data is already in sorting, some sorting technique is there. With animation, I will show. There you will get the clarity. Okay. Right. Who asked this doubt? Can you please confirm? Clear?
Yeah, okay, sir.
Right. So
Yeah,
now, right. I want to calculate the sum of two matrices. How you can able to do? Very simple, sir. I am preparing algorithm for this. Algorithm of, sir, you have to give two matrices, A comma B. Assume n by m is nothing but order of those two matrices, n rows, m columns. So I am not writing the code for reading matrix, all these things. Directly I am writing business logic. I is equal to 0, I less than n, I plus plus. Similarly, sir, for j is equal to 0, j less than n, j plus plus. Okay. So here I am going to take C of ij, matrix is equal to So A of ij plus B of ij. I think no need to explain this. So if you want just one small example, I will take. Okay. So consider, sir, I am taking, okay, I am taking, so n value as a 2, m value as a 3. That means, sorry, sir, 2 under 2, 2 by 2 matrix. So I have A array is there something like 1 0 0 1, let it be. So B array is there something like 1 2 3 4. So this one will become 0th row, first row, 0th column, first column, 0th row, first row, 0th column, first column. So when I is equal to 0, j is equal to 0, take these two elements. A of ij means A of 0 0, B of 0 0. Bring these two values into addition. Sir, how to calculate next one? I is equal to 0, j value will become 1. So I is equal to 0, j value will become 1. That means this value and 0 1 this value, add these two. Then these two values. So then these two values. Like this we are going to get addition. So this is nothing but how it is. Sir, now you have to tell how much time is required for executing this line. Please confirm everyone.
N plus 1.
Very good. Majority of the people are going to take n plus 1. But a small modification I am doing. Consider this size is also n. Now tell me this line how many times it is going to execute. Think a bit logically and tell me.
N square.
Yes, please, everyone.
N
So,
square.
n plus 1 times this loop is also going to execute. And for every n value, right? That's why n into n plus 1. Right. So it will become n square plus 1. n square plus 1. Like this I am taking. Sir, how many times this loop is going to execute? This statement. Please respond.
N square plus 1.
N times.
Vishal, why you are telling n? Right.
N square. N
Yeah.
square.
Right.
It's
N
square,
square times. One time false. Yeah. Okay. No problem.
Sorry, sir, it was typo.
One
Okay,
time,
no.
one time 4, sir. That's why.
Correct. So time complexity of, sir, sum of two matrices. Sum of two matrices is nothing but, sir, n plus 1 plus n square plus 1. Okay. Sir, plus n square. So I can able to consider, sir, 2n square. Okay. 2n square. So plus n plus 2. This is nothing but type complexity. It is also something like order of n square. Okay.
Sir, in the
I have
second.
a question, sir.
In the
Sir, when
second
you
line,
multiply, yes, sir, in second line, when we
For the second
multiply
for
n
loop,
into
it should
n plus
be n square plus n, right?
correct, sir.
yeah, that was my doubts.
Yeah, n square plus n. Sir, this one n square only, right? Yeah, right. This
It'll
one,
just be 2n square plus n plus 1.
this one n square. No, this loop is going to execute n times true. So one time false. That means this one will execute n times true. This into n times 2. Right, n square only. So here n square plus n. Okay. And here also, I think additionally, we need to take n plus 1, n square plus n. So here 2n square plus 2n plus 1. Right. Right. Sir, clear, right? Everyone, please confirm. Is it clear? Right, sir.
Sir, I have a question, sir. So in the last line, when we are comparing and creating this, like O of n square, so n is negligible on that time?
Yeah, n is also negligible, sir. So higher order priority will come into the picture. So whether it is a constant expression or linear equation or quadratic or cubic, that power highest value will be considered into the situation.
Okay.
Right.
Sir, J less than M it will become no, sir.
Yes, ma'am. But I am telling both matrices are having n by n order.
Okay, sir.
Otherwise, calculation will become very difficult for us, right? See, at the top level only we are considering. Internally, n number of things will be there. Okay.
Okay, sir.
Right. Why second for loop is executing n square plus 1 n square plus n times, because n times true from this for loop. This is also for loop, so n plus 1 times. If you multiply, n into n will become n square plus n into 1 will become n. Simple. Right. So tomorrow we will meet for the continuation. Tomorrow we are going to talk about a biggest thing, that is sum of multiplication of two matrices. That algorithm we will see, and then so how you can able to measure time complexities, best case, worst case, average case. That part we will discuss tomorrow. Okay, right, sir. The people who have not received any running, so please share your mail IDs.